Hello everyone, in this video we are going to be discussing about normalization. I have briefly discussed normalization in one of my previous videos. I will link it in the description of this video, you can check that out. So let us start with normalization. What is normalization basically? Normalization is the process of taking a relation schema through a series of tests. These tests are also called as normal forms, okay? And then seeing whether these relation schemas satisfies the conditions led by the test. If it does, then we say that the relation schema is in this particular normal form. And if it does not pass the conditions of the test, what we do is we decompose the relation schema into smaller relation schemas such that those smaller relation schemas can satisfy the conditions of that particular test. Okay, so this is what is called as normalization. Keep doing the tests in increasing order of the strictness and evaluate whether your relation schema is good or not. So normalization, what kind of measure it is? It is used to measure whether the database design is good or whether the quality of your relation schema is good or is it not good. It is used to evaluate the goodness of a relation schema. Okay, so how can you see it? For example, if we talk about real life scenarios, what we do if we manufacture a product and we want to see whether the quality of that product is good enough, we will take it to a certification board and we will see whether our product passes those tests. Let's say ABC test, if it passes, and if it does pass that ABC test, we say that our product is ABC test certified, which gives some clue to the customer that our product is good. And if it does not satisfy those tests or is that ABC test, what we do, whatever claims we are not able to satisfy, we will improve the product according to that, and then we will again go through the same certification and say whether our product has pass the certification or not pass the certification. Similar is with the relation schemas. What we do, we take the relation schema, we see whether it passes these tests, normal forms, and if it does, then we say that our relation schema is good. Okay, so basically we have 4 normal forms which we really give importance to. First normal form, second normal form, third normal form, and BCNF, Boyce Codd normal form. And this is the order of increasing of strictness. Every relation schema which is in BCNF is also in 3NF. Every relation schema which is in 3NF is also in 2NF and 1NF. Okay, and this is how it increases. For example, if a relation schema is in BCNF, you can see with the same analogy of a testing of that certification, that if you have qualified the higher certification, it means you have already crossed the lower ones, right? So similar is with this case. If a relation schema is in BCNF, it means it has already cleared 1NF, 2NF, 3NF, and now also it's in BCNF, right? So that is what is normal form of a relation schema. What is a normal form? Let's say if you are told to find out the normal form of a relation schema, what is the normal form of this particular relation schema? The normal form of any relation schema is the highest normal form condition that it meets. Okay, so and it indicates to which degree that relation schema has been normalized. So if it is in BCNF, then it means that all this so if a relation schema has passed the tests of 1NF, 2NF, 3NF and BCNF, all the tests, then since BCNF is the highest test or the highest quality significator, we will say that the relation schema is in BCNF. Similarly, if a relation schema is all in 1NF, 2NF, 3NF, then we will say that the relation schema is in 3NF, because this is the highest normal form condition that it meets. Okay, because the strictness keeps increasing in this order. Okay, so normalization is used to see whether our database design is good or it is not good. But normalization alone cannot guarantee a good database design. There are some other properties also that we use in order to see whether our database design is good or not. Alone we cannot say. Of course, it is one of the indicators of good quality of a relation schema, but in isolation we can never say that this is the only way. Like if the relation schema is in, let's say, BCNF, it's a good relation schema or it is in good database design. There are several other properties that need to be met for a relation schema to be good. Now let's see what are those properties. 2 properties are there. One is lossless join. or non-additive property. Okay, and the second is dependency preserving. Okay, so what do these properties tell? These properties tell, the first property, lossless joins, say that there ensures that there are no spurious tuple generation problem in our relation schema. Okay, so what are we doing? First we will, let's say if we have a relation schema, we will see whether it is qualifying a particular normal form or not, and if it does not qualify, what we do, we break it into smaller relation schemas. Okay, let's say this was of 4 attributes, and let's say we have broken it into 2 relation schemas, this and this. Okay, so these tables are not like these tables. After decomposition, we have to make sure that this property ensures that there are no spurious tuple generation happening because of this decomposition. Okay, so what is this problem? I have also discussed in other video. I will relate to it. All these both problems, that this problem that is happening, or the reasons why we are doing normalization, that I have discussed in that video. What are the problems that occur in relation schema generally? So why should we do normalization? Okay, so what does this property say? This property ensures that spurious tuple generation problem should not occur. Okay, there are spurious tuples, that is, these tuples do not really exist, but they are just generated by this decomposition. Okay, that should not happen at all. The second property is dependency preserving property. What does it say? It says that every functional dependency should be represented in some relation schema after the decomposition. For example, if you have decomposed this relation schema into these 2 relation schemas, the functional dependencies that used to hold on this particular relation schema, every functional dependency should be represented in some relation schema that is resulted after decomposition. So these 2 properties should also hold when we are talking about decomposition of relation schemas or after normalization. Okay, so in addition to normalization, when these properties also hold, then we say that our database design is good. But sometimes what happens, we are not able to ensure that these 2 properties exist or these 2 properties satisfy the relation schema. So sometimes we compromise this particular property, but this property is very critical and this should always satisfy. We will see in examples how it always satisfies and how to ensure that this always satisfies, but this property is extremely critical and we do not skip through this property. We always make sure that our relation schemas after decomposition, while doing the normalization tests, they always pass. Okay, so what is normalization? What are we doing normalization based on? Like, what is the basic tool that we are using in normalization? We are using, the tool that is being used is functional dependencies among the attributes of a relation schema. Okay, based on the functional dependencies only this entire process is carried out, where we evaluate whether the relation schema satisfies a particular normal form or it does not satisfy. Okay, so what we can finally we can say that normalization of data is a process of analyzing the relation schema based on the primary key and the functional dependencies. Okay, based on the primary key and the functional dependencies that hold on that particular relation schema. But why we are doing normalization? We are doing normalization to achieve these 2 properties. We are doing it to minimize redundancy and minimize insertion, deletion, updation anomalies. I have talked about this in the other video, how redundancy happens across different relation schemas and how insertion, deletion, updation anomalies happen in various relation schemas or in various tuples in my introduction to normalization video. Please do watch that. So in order to get rid of these 2 issues, right, redundancy and insertion, deletion, updation anomalies, we do normalization. So what we are trying to achieve by doing normalization or by testing the relation schemas, we are trying to minimize the redundancy of the relation schemas, and we are trying to minimize the insertion, deletion, updation anomalies. Okay, so this is what the normalization says. And apart from that, it is also important to see that it's not always necessary that we always normalize it to the highest normal form. It's not necessary that since we have BCNF, every relation schema should be normalized until BCNF, otherwise it's not good enough. That is not how it should be. Maybe till 3NF only it is good. Even if it is normalized till third normal form, maybe it is good. Okay, so you do not need to always go to the highest normal form. So there are certain reasons why we might avoid normalizing the relation schemas even more, okay, based on complexity, based on what you desire and all of that stuff. Okay, so it is not always important that we normalize to the highest normal form. Okay, and this you understood, right, that this is the increasing strictness. Whichever relation schema is in BCNF, it means it is already in third NF. Third NF, if a relation schema is in, it means it is already in 2NF and 1NF. Okay, so this is majorly about normalization. And what is the normal form of a relation refers to the highest normal form condition that it meets. What is the highest one that we see? Okay, so this is about normalization. We'll discuss about first normal form. Okay, so I checked that the video is already long enough. I will cover the first normal form in the next video with examples, so that you get a very clear idea of how the normal forms works and how do normalization work. If you like this video, press the like button, subscribe to my channel and hit the notification bell so that you get notified every time I put up a new video, and share with your friends and colleagues if you think they would find it useful. I'll see you in my next one. Bye.